Point 2, a line of best fit. So we'll see what a line of best fit is and when we're looking at our scatter plots. So here's some information at first how to draw a scatter plot. I'm not going to read through all the points. You can do that yourselves, but we will use each of these points when drawing our scatter plots. Okay, you see at the bottom here there's a warm-up. We're not going to do the warm-up because we need to be in the classroom for that. We're basically be working in groups and measuring each other's arm length and so on in order to get the information to draw the scatter plot. But we're not going to do that. So we're going to move past that to our line of best fit. So basically what a line of best fit, it must follow the data trend through as many points as possible. There should be an equal number of points above and below the line. Draw a straight line through the points, extend your line the length of the graph, and do not connect each individual point. Okay, it's supposed to be just a single straight line. It's not supposed to connect the dots, basically. Okay? And then drawing conclusion from the data. So we'll see all that when we're working through these questions. So we'll get to our first example here. So it gives us the information. We didn't have to find this ourselves. So the table shows the population in any town in Canada from 1980 to 2000. Okay, so the information gives us is year since 1980. So this would be 0 would be at 1980. 5 years after would be 1985. 10 years after would be 1990, and so on. Okay, so that's what those numbers mean, and this shows the population. Okay, at this year, this is what the population was. Okay, so what we have to do is draw a scatter plot. So our first step was to look at our independent variable. So here, we know our independent variable is always the timeline. So this is our independent variable, and we're going to determine a scale to use for our x-axis. So, I mean, anything that will fit all these numbers in. So 0 would be here. I'm just going to count by 5. By skipping one though. So skip 5, again 10, 15, 20. I mean, you could have gone a bit more, but it's fine. Population 1,000. So whenever you have something like this, we can see our first number starts really large. So this means, this kind of squiggly line I wrote, it means we're skipping a bunch of numbers and we're going to start at 3,000. Okay, that's what that means. So we don't have to go all the way up to 3,000. Okay, this will show a much better scale. So, I mean, I'm just going to count by 50s. Same way we skipped one here. Skip 1, 50, 3,100, 3,150, 3,200, 250, 3,300. Okay, so this is so far how I set it up. We're gonna have to now plot our points. So, year since 1980, 0. So at 1980, the population was 3,056. So it's gonna be about right here, just above 3,050. 5 years, we find 5 years. This is our x value. X value is 5, y value is 3,115. So 3,115 will be about here. 10 years after, so we find 10 and line it up with 3,162. So be about here. 15 years, 3,204. Just going to be right above 3,200. And then 20 years after, 3,256. So it'll be just over 3,250. Okay, so we can see it's following a trend, right? It's basically an upward trend. Now it says draw a line of best fit. So I mean, it's not supposed to connect the dots, but our dots here are pretty straight. Let's see. I mean, there's what a line of best fit would look like. I mean, it could have been a little up more, but this is fine. This will help us find the trend of this town for any year, basically. Okay? Use your trend line to predict the population in 1993. So, if we know our 0 is 1980, we know 13 years after will be 1993. So if this is 10 years, this would be 13 years right there. Use the ruler to go up. Where would our point be? Around here. So So at this point in the graph, it lines up with about 3,000, we can say 85, right? It's going to be between these 2 years. So 3,085 is about right. Okay, so now it's saying predict the population of 2005. So 2005 would be one further. So we can say this would be 25 years after. So 25 years after 1980 is 2005. We may have to extend our line of best fit a bit. It's going to be right here. Where is that? Probably around 3,310. Okay, so that's how we would use our line of best fit to basically extrapolate. So extrapolate would mean going past of the information we had and predicting in the future. Okay, it only had the population up to the year 2000, but okay, let's predict. Okay, that would be extrapolating. Interpolating is the information we have already, find something in between that information. Okay? Next page here. So for this it says to draw a line of best fit for each one and then write a few words about it describing its relationship. Okay, so we're going to say, is it falling upwards, is it falling downwards? Does it have a relationship or no relationship? Is it strong or weak? And is it linear or non-linear? Okay, so first one, let's draw our line of best fit. Okay, that looks pretty good. What does this look like? So we can say it's falling downwards, right? We can see as it goes to the right, it's going down. So we can put falling downwards. Okay, what else could we say? You know, it looks like a pretty strong relationship. Strong relationship, and it's linear. We can tell it's a line, it's going in the direction of a line. So we'll say linear. So it's falling downwards, a strong linear relationship. Okay, our next one, you know what? The dots aren't as close together, but we can still draw our line of best fit. Okay, so this is our line of best fit. It's still a linear relationship, right? So it's rising upwards. Rising upwards. Weak relationship, right? These dots are very close together in our first one. These ones are more spread out, but it's still a linear relationship. We'll say a weak relationship. We'll say linear. Okay. This next one, dots are all over the place, pretty random. We'll just say no relationship. You don't really need to say anything else. It's not linear. There's just no relationship at all. This next one, you know what? It's not really linear, right? It's just to only draw the line of best fit for the ones that are linear. This one's not linear. You can say it's a strong non-linear relationship. Our next one looks like no relationship. Looks like random again, so no relationship. Our next one, okay, this is a linear relationship, so we can draw our line of best fit. Okay, so it's going to be rising upwards. Strong linear relationship. Okay. Our next one, you know what? It looks like it is some kind of relationship. As it goes to the right, it is going down, so I mean, this would be our line of best fit. So it's going to be falling downwards. weak, linear. Next one, you know what? This is what we would call a sine function, okay? You won't learn about this for a few years, but it's not a linear relation. So we'll say it's strong, non-linear. We can see the dots are pretty, they're staying in the same pattern, none are out to the side, and it's non-linear. And the last one, we can say that it's a fairly strong relation. We'll just say strong, non-linear. Okay, so this is how you would basically describe these. So it's easy to tell if they're linear or non-linear. They follow the path of a line. And see if it's a strong relationship or not. If the line dots are really close together like this one, it's a strong relationship. If they're more spread out like this one, it's a weak relationship. And yeah, if you have any questions about this, let me know.